The educational booster pack is an interesting product. It's got quite some goodies on there. A number of sensors, buttons, a joystick, and this LCD screen. And it also comes with a number of examples. And if you have one of the popular LaunchPads like the MSP430, you're good. There is an example for all the things on board. But I'm running here with a Hercules microcontroller, a safety microcontroller that is specialized in automotive and medical and industrial applications. And there are no examples to make that microcontroller work with the LCD screen here on the booster pack. So what I've done is I've taken the code for the MSP430 and I have ported that to the Hercules family. I'll explain you how that works. The first thing that I do is check at the schematics to see what lines I have to drive. And for the LCD screen that we see here, we have three types of signals. We have signals that we can just control with generic I/O pins, and those are the reset and the data command pin. So it's okay if I have a pin on my Hercules that I can just drive high and low to fulfill that functionality. The backlight of the LCD that requires a pulse width modulated signal, so it would be nice if that one links back to one of the PWM pins on the Hercules. If not, it would also be okay if it goes to a generic GIO pin. That means that I can switch off and on the light and maybe bit bang some PWM in there. But still I prefer to have it directly to one of the PWM pins. And then we have the communication via SPI. We need a chip select, a master out slave in, and a clock. So I hope that these three pins nicely match to functional SPI pins on the Hercules module. I could use the schematic of the booster pack and the LaunchPad to see which pins of the LCD match with which pins of the Hercules, but I have written this down to make it easier, and I have good news. I have a match for all of the pins. So if we look at the SPI, where we need the clock, MOSI and chip select, you can see that it nicely matched with the same pins of the Hercules SPI module 3. So the clock, MOSI and chip select are covered. The backlight PWM nicely goes to one of the PWM modules on the Hercules, and the two GIO signals, the reset and the data command, nicely match with a generic input output pin. So that's good news for me. It means that I don't have to worry about botch wires or adapters. I can just plug the booster pack on the LaunchPad and get started with the firmware. Now that we know what functionality we need, we can start with enabling the drivers. So we'll need the GIO driver, the MIPSPI 3 driver and the PWM one. So those three are turned on. And then we can go ahead and configure the individual modules. For GIO, we needed port A pin 0 and port P pin 3. So both of them need to be output. So on port A, we put this flag here on number 0, so to make that one an output pin, and on port B, we do the same for pin 3. All the others we leave as is. So what we have now is 2 pins assigned as output pins, and we can control them in our firmware. A little bit more work is required in the PWM port. There we have to check that PWM 6 is turned on, because that's the pin that we're talking to. And on that module 6, we need to set the frequency and the duty cycle. I have set the frequency to above the audible range, because I don't want the beep in my ear. And I have set the duty cycle to 100%. That means that the backlight will light up with 100% at the start, but we can change that in the firmware, so we can make that any percentage, and that way we can make the backlight more bright or more dim. And now we're ready for the last and the toughest part, and that is the SPI. So we have selected MIPSPI 3 module as the one that we're going to use for the LCD. We didn't really select it, we had to, because that's the pins that are going to the LCD. And there are 3 big things that we need to set up here. The data formats, the transfer groups, and the port, the functional assignment. I'll start with the easiest ones, and that's the functional assignment of the pins. In Halcogen you can multiplex SPI pins as generic I/O or as functional SPI, And for the 3 pins that we are using, and that is the Ship Select 3, the clock and the MOSI, we need to set them to SPI. The other ones we can leave to GIO and reuse later for generic use. So you can see here that Ship Select 2 is SPI, and then here on top the master out, slave in, and the clock. So these 3 pins are the ones we used. They are now functional and we can drive them via the SPI module. And then we have the data formats and the transfer groups, 2 separate things that define how the SPI module is going to communicate with our LCD screen. I'll start with the data format. That's a generic configuration that tells the speed of our communication, the number of bits in each word that we're going to send to the LCD, if it's the least significant or the most significant bit first, and some other options. Significant here is the clock polarity and the clock phase. That is something that needs to be correct because we have 4 different SPI modes, mode 0 up to 3, and based on which mode you have, the data is put ready on a particular phase of the clock, and the data is sampled on a particular phase. So that means on the rising edge or on the falling edge, and you need to have these right to have a correct communication. For the LCD display that we're using, we need mode 0, and this setting here, these 2 settings reflect that mode 0. For the rest, we have a character length of 8 in my first data format 0 and 16 in data format 1, and no parity and no enablement used here. So these are the abstract data formats that we'll use later. We'll use them in our transfer groups, because the transfer groups is how we talk in our firmware with the SPI module. There we set the buffer types. How many words are we sending in one communication? How do we buffer different types of settings? Which ship select do we choose for that particular transfer group? And which data format. That data format reflects back on the one that we have set a few seconds ago. So the first group here, transfer group 0, uses data format 0. That means 8 bits. I'm using ship select 2 and I'm sending 1 word each time. So it's not really buffered, right? If you send 1 word, that means you send it directly. My second group is the 16-bit group. So that has everything identical as here, but it's using data format 1. And if we see here, data format 1 was the 16-bit one. I've also configured but not used yet a third group, and that is transfer group 2 with a buffer length of 103 words. 103 matches the size of 1 line of a bitmap that I'm trying to send to the LCD display. So later on, I'm trying to use the buffered mode to send those image lines very fast. I want to send them line by line instead of pixel by pixel, and this will help me here. And that concludes all the work we have to do in Halcogen. We have configured the GIO, the PWM and the SPI modules. So we can now use the code generator to generate our framework and generate the initialization code, and then go to Code Composer Studio to write the firmware. And I'll cover that in the next video.